Hoy en Alas decolamos con The Discovery Channel en el F6F Hellcat. Luego de entrar en servicio con la Fuerza Naval Norteamericana en 1942, el F6F se convirtió en factor dominante de la campaña del Pacífico, aunque carecía de la maniobrabilidad de su adversario principal, el Cero, así como de mejor armadura y poder de fuego, demostró ser una combinación mortal. De más de 6.000 aviones derribados en el Pacífico, el 80% enfrentó su destino frente a las garras del Hellcat. Hoy volamos alto con el F6F Hellcat en Alas. Durante el transcurso de la Segunda Guerra Mundial, la Fuerza Aérea del Ejército produjo varios aviones que se convirtieron en leyendas. El P-47 Thunderbolt, el P-39 Lightning y el P-51 Mustang. Sin embargo, ninguno de ellos alcanzaba el promedio destructor de los aviones sólidamente construidos y casi redondos, conocidos como F6F Hellcat. El modelo se desarrolló después de mucho pensarlo y se puso en producción por Grumman. Llegó a alcanzar un promedio de 19 aviones enemigos derribados por cada F6F perdido en combate. Sobre estas cifras puede juzgarse al F6F Hellcat como una de las historias de más éxito significativas de la aviación de la Segunda Guerra. Además, era extremadamente efectivo como bombardero de ataque en tierra y mar. Tenía un alto desempeño general y era una opción de inmenso valor en la guerra. En 1942, cuando el Hellcat entró en servicio por primera vez, el concepto que lo respaldaba tenía poco más de un año. En un periodo de 3 años se produjeron no menos de 12.000 unidades, todas de la misma fábrica, lo que en sí mismo es una hazaña de ingeniería. Esto se hace más impresionante cuando se considera en conjunto el hecho de que era el segundo bombardero monomotor que producía Grumman y solo el tercero aceptado por la Fuerza Naval. Por otra parte, el Cuerpo Aéreo del Ejército tenía experiencia con diseños de bombarderos monomotores desde comienzos de los años 30. Ya para 1932 estaban en servicio los pequeños y fornidos Boeing P-26, apodados Puppy Shooter. En enero de 1935, Grumman vendió a la naval un bombardero regordete, el XF-2F.
Since the delivery of the first one, Grumman has had fighter types under contract for the Navy without interruption. Their next plane was the F3F, which ironed out some of the vices of the F2F with more maneuverability and better directional stability. It was adopted by the Navy in relatively large numbers. These were the last biplane fighters produced in the U.S. The drag problems of the strut bracing of biplane wings so hampered speed that it was evident that they would be replaced by monoplanes, despite the twin problems for the Navy of the higher landing speeds of the single-wing fighters and the problem of stowage of their larger shapes within the confines of the fighting ships. The biplane had its inherent advantages of maneuverability, slower landing and takeoff speeds, and the sturdiness of their bracing. However, these factors were irrelevant in the face of the speed advantage of the modern monoplanes, and the era of the biplane was well over by the time the war broke out. By the late 1930s, even U.S. bombers had long been monoplanes, whose sleek designs gave them greater speed than the Navy's biplane fighters. The Navy had to turn its attention to solving the problems in carrier use of monowing fighters, and tests were conducted employing examples of all Army fighters then in production with pretty disappointing results. It was a case of building new planes for practical carrier deployment. Stripped of one wing, but otherwise not radically altered, the F3F emerged as the XF4F in 1936, but it offered little improvement on the biplane's performance and was abandoned and replaced with a new design, the XF4F2. The new shape was quickly refined in response to strong interest not only from the United States Navy, but from the British and French fleets as well. During 1939, a new variant, the F4F3, was settled, and contracts were signed with all three navies, though none of the French planes had been delivered by the time Hitler's Blitzkrieg had knocked that nation out of the combat. Named the Wildcat, the new plane employed Grumman's answer to the problems of stowage and movement of the planes around the carriers, a folding wing. Cranked back alongside the fuselage, this novel solution reduced the aircraft's demand for space, although some of the early export models had fixed wings. The stout shape was extremely clever. In spite of its stubbiness, it was aerodynamically very efficient. Defying the trend to inline engines that European designs had led, Grumman stuck with the radial power plant, valuing the extra resilience they offered and their lower demand for maintenance hours, easing the burden on carrier crews operating at sea. Though outmoded in its original role, the plane stayed in production with little refinement right through to the end of World War II. General Motors produced the Wildcat in the thousands for supply to the U.S. and British navies. By the end of 1939, the war clouds over Europe had broken, unleashing a storm of destruction as German forces overran Poland and France behind the stunning assault of the Luftwaffe's air power. The British Navy's F4Fs, under their designation the Martlet, were actually credited with the first kill of World War II by a U.S.-built airplane when two British-flown Martlets identified and intercepted a Junkers 88 medium bomber over the United Kingdom. Though the 88 was a fast plane for its type, it was no match for the stout little Grumman planes, and it was quickly dispatched.
El brazo aéreo de la flota normalmente volaba Martlet desde portaaviones y en el papel para que había sido diseñado cuando la Fuerza Naval Real se encontró involucrada en la enorme refriega que fue la campaña del Atlántico.
Trying to protect the convoys and keep the sea lanes open, the F4Fs were employed in that cold and bleak environment. They provided invaluable service, often working from small carriers with very limited flight decks, an ability that ensured their continued service in the years to come. Back in Bethpage, Grumman was well aware that the Wildcat was limited and that the Navy would need a larger, more powerful fighter. Leroy Grumman, the company's president and chief engineer, had been involved in discussion with the Navy to determine their longer-term need for a more advanced plane. Within the Grumman philosophy, build it strong and build it simple, the engineers hammered out a new design to improve on the Wildcat. To provide any marked improvement resulted in a completely new plane being developed. The Navy flyers of the Wildcat were clear on what they wanted: more speed. To provide this meant the use of a more powerful engine, and this meant that the entire structure had to be strengthened. The new plane would be 3,000 pounds, or over 60% heavier than the Wildcat. The previous undercarriage would have been totally inadequate, and in designing a totally new system, the engineers also repositioned it beneath the wings, creating a wider track and making the plane more forgiving in carrier landings. It was Japanese carrier forces that would bring America into the war.
Cuando los japoneses atacaron Pearl Harbor en diciembre de 1941, destruyeron una parte importante de la fortaleza de la naval norteamericana en el Pacífico. Pero en ese momento, las fuerzas de portaaviones no estaban en puerto y se conservaron. En las batallas subsiguientes en el Mar del Coral y Midway, estos barcos fueron cruciales, ya que el resultado de esas batallas cerró efectivamente la fase de la expansión japonesa. Durante ambas campañas, el único bombardero disponible en la Fuerza Naval Norteamericana era el F6F, y aun cuando prestó un servicio valioso, trabajaban bajo presión. El Wildcat era el más lento de todos los bombarderos norteamericanos en la guerra. Sin embargo, tuvieron bastante éxito. Esta carga generosa en el ala les daba mayor maniobrabilidad y tasa de elevación que algunos de sus contemporáneos más rápidos, y con el apoyo pragmático de tácticas bien concebidas, se mantuvieron contra los aviones japoneses. La ferocidad de la guerra naval sobre Japón, que luchó con tenacidad y bravura, es leyenda ahora. Las difíciles victorias de los Wildcat contra los Zeros japoneses eran su mayor crédito.
Against the Japanese Zeros were a major credit to them.
When we found out that we were going to be under attack by the it was really kind of funny because all the veterans were getting ready to duck under the, we're sitting up on the flight deck. We wanted to see what happened, and when the first strafing made their run, you just couldn't find a soul on the deck after that. So we learned real fast that it wasn't a picnic out there.
El Zero de Mitsubishi fue otra leyenda de la Segunda Guerra. Extremadamente liviano, había sido diseñado con 3 criterios. El más importante, la maniobrabilidad, seguido del largo alcance y una velocidad al menos competitiva con bombarderos de otras naciones. Aun cuando podía alcanzar a cualquier avión aliado, su simplicidad y levedad lo hicieron vulnerable al enemigo que rehusaba jugar sus reglas. Carecía de golpe con sus cañones y de la capacidad de absorberlos él mismo. Por su competitividad se emplearon tácticas especiales para que el Wildcat pudiera enfrentarlo, pero era claro que se necesitaba un avión más veloz que subordinara a los Zeros de una vez por todas. Tal avión ya estaba en la mesa de dibujo, el F-4U Corsair de James Book. Este poderoso bombardero con su distintivo aire taimado había estado en desarrollo por algún tiempo y se proyectaba para el uso de los portaaviones Essex, que eran lo suficientemente grandes para proveer espacio para el aterrizaje y despegue de aviones grandes. Pero con Estados Unidos en la guerra y con el Corsair aún en desarrollo, la Fuerza Naval tuvo que buscar otra alternativa para proveer el bombardero más poderoso que se necesitaba para reemplazar al Wildcat. Mientras tanto, el nuevo concepto de Grumman alcanzaba su momento. Diseñado como el F6F, el proyecto totalmente secreto estaba siendo presentado a la Fuerza Naval como un avión que podía entrar en producción tan rápidamente como se diera la orden.
Though conventional and strongly resembling the Wildcat, it was a totally new plane down to the last nut and bolt. But it still reflected the principle of keeping things strong and simple. The Navy placed its first order on June 30th, 1941, and the plane, given the name Hellcat, went into production. All manufacture of the Wildcat and much of that of the new Grumman Avenger dive bomber was transferred to General Motors, and Grumman turned their whole Bethpage plant to the Hellcat. The first flight took place less than 12 months after the order was placed on June 26, 1942, and production planes were being completed only 5 months after that. A feature that the Hellcat shared with its smaller stablemate, the F4F, was its folding wings, as the innovation had proved itself a real success, and there was no point in changing it. A sturdy strut undercarriage, totally new on a Grumman plane, had been adopted to deal with the heavy load of the new fighter. The great bulk of the stubby design was to be propelled by the 2,000 horsepower Pratt & Whitney R2800 double wasp engine. Both the engine and the undercarriage were only slightly modified as the plane evolved. You can get some idea of the size of the aircraft as crew climb aboard it. Its bulk would demand too much for the small escort carriers, so these would remain the domain of the Wildcat with its short takeoff requirements. As the designers and engineers refined and perfected the design, the prototypes were virtually hand-built by the company's most skilled tradesmen. Here, ground crew tap the wing with a mallet to see if any hand tools have been left inside during the wing's construction. After it was sealed, a wrench caught between gears or pulleys could destroy the entire project before it got off the ground. Using the same cartridge-like starter of earlier Grumman aircraft, the F6F is being readied for ignition. With the successful firing of the engine, the pilot directs the ground crew to remove the chocks, and the Hellcat is ready to take off. In some ways, the success of the Hellcat is a model of the cooperative effort by the Defense Forces and American industry to meet the demands of war. The nation had found itself plunged into the war with little overt preparation. In fighter aircraft, there were insufficient numbers of mostly outdated designs, and yet in a short time, the U.S. was turning out planes that could not only do the jobs given them, but do them very well. In addition, they were being produced in numbers that were well beyond the capacity of the Axis powers. What the U.S. Navy needed and what the F6F provided was a plane that made optimum use of established and proven technology and that could be delivered quickly in large numbers. The engineering might of North American industry was brought to bear as a potent military advantage for the Allies. While Nazi designers were working with new, still largely theoretical technology in developing jet and rocket-powered planes to regain their previous advantage, their existing arsenal was confronted by overwhelming numbers of excellent conventional aircraft. The Germans' new technology would arrive too late and in insufficient quantity to swing the combat around. The Hellcat, typical of most U.S. fighters, was much heavier than its opponents, but offered comparable or better performance, in conjunction with more firepower and greater armor protection for its pilots. These planes were more likely to return to base after sustaining damage, so the attrition in U.S. pilots was far lower than their opponents. The U.S. pilots, well-trained and flying better planes, survived their early combat exposure to become experienced warriors. But the Japanese forces, flying planes that relied on flight rather than protection, quickly lost their core of battle-skilled veterans. After the first 2 years of the wider conflict in the Pacific and Asia, Japanese planes were being flown into battle by pilots who were not only inexperienced in combat, but virtually untrained. Rushed into production to cover the delays in the Corsair project, the Hellcat impressed the Navy. With the expanding need for planes, it was easy to convince the Navy to purchase the Hellcat in large numbers.
Yeah, it was a very maneuverable airplane. It did aerobatics. It did everything that was demanded of it. And it was a green pilot's airplane, and we had very few problems with maintenance or the aircraft itself, or with flying it. We all flew it.
The nation went to war in the armaments factory as it did on the battlefield. Eventually, the availability of the instruments of destruction would be the deciding factor in the outcome of the war. Here, Grumman made a major contribution. Not only did it deliver a plane that could be quickly deployed to do the job, but it delivered the machinery to make them. The workforce, the techniques and skills needed were assembled and trained to produce the aircraft in phenomenal numbers. Women workers, young and old, joined the workforce, and even the disabled found places in the mobilization of industry to meet the war's demand. Here, the massive 2800 double wasp engines are fitted, and the propellers with their complicated gear mechanisms are assembled. The major sub-assemblies, prepared in their own sections of the plant, are brought together in the final assembly area to make up the plane. When the green light was given, the Hellcats proliferated with astounding rapidity. Never before or since has the aviation industry seen so many of any type of aircraft sourced from one single plant anywhere in the world. Yet within 3 short years of the delivery of the first Hellcat, the production line had ceased to be. During the Hellcat's entire production run, over 12,000 aircraft were manufactured. Remarkably, in that figure, there were only 2 major subtypes, and these were so close externally that it's hard to pick the difference. The Model 3 can be identified by the extra window behind the cockpit, which was deleted as being of little value. The F6F5 was given more power through water injection for the engine, and also had various other, mostly minor changes made, notably bomb mounts under the wings. For the most part, the airframe remained unchanged, and this obviously was one of the factors that made possible the tremendous output from the Bethpage plant in such a short time. But the most important reason for this was the superb organization of the factory, a model of quality mass production. Over the production life of the Hellcat, even the paintwork varied only once, in changing from the 3-tone blue early camouflage to the overall dark navy blue, almost a gloss black, which remained in use till well after the war. Here, a finished Hellcat leaves the paint shop, fully inspected by Grumman's ground personnel. Next, it must go through hands-on testing by the Grumman test pilots. Their job was to look for faults from construction failures, an inherently risky business, before planes were cleared for delivery. In this dangerous job worked some of the unsung heroes of the war, and it is of interest to note that several of these pilots were women. The work of the female ferry pilots in the U.S., flying planes from the factories to bases, is better known. But these company pilots, flight testing Hellcats, like the women on the factory floor building the planes or those in the control tower, made a major contribution to the war effort, and their particular courage and dedication deserves note. In this case, the product of their labor, the F6F, was, as far as the Pacific Theater was concerned, the key to victory. Daily, the ferry pilots would come to collect the planes as they were cleared for delivery. The Hellcats rolled from the factory in a constant flow. This mammoth industrial activity, reflected in hundreds of other plants around the country, was to create the situation whereby war's end, the United States industrial output had soared to be larger than that of all the other combatants combined.
The squadron that I joined was VF-15 out of Air Group 15, and it was a a highly decorated fighter squadron, just having come out of the Battle of the Philippine Sea and the later stages of the Marianas Turkey Shoot, in which the Japanese air opposition was still there.
Although a few Hellcats operated from land bases in the Pacific, most, like the Wildcats, were deployed to carriers. Navy and Marine F6Fs crewed the larger carriers like the Essex class as rapidly as they could be produced. Within weeks of rolling from the factory, the Hellcats would be employed thousands of miles away at sea, doing what they were designed for, waging war. The limitations of carrier space dictate a need for Navy planes to be capable of varied missions, since accommodating specific types for different roles is obviously inefficient. So, where a tactical attack capacity may be desired for the Army, it is essential in a naval fighter. The Hellcat had air-to-surface capability included from the start, and with its high rate of dive, it excelled in ground attack duties. The Pacific Fleet was subject to daring aerial attack from Japanese Army and Navy planes throughout the war, from the ferocious, even contests of the early battles to the later one-sided affairs culminating in the kamikaze attacks.
Con los japoneses escasos de pilotos y de combustible, los ataques suicidas presenciaron a unos aviadores devaluados, convertidos simplemente en componentes de los aviones, que eran bombas guiadas. Dejaban la base con combustible suficiente para una sola vía, con un objetivo: hundir un portaaviones. A medida que la guerra progresaba, los portaaviones se convertían en los blancos más importantes. El hecho de que se hubieran salvado los portaaviones norteamericanos en Pearl Harbor detuvo el avance japonés, y fueron las pérdidas de portaaviones japoneses en Midway, pérdidas que no le hacían bien a Japón, las que decidieron la cuestión. No había mejor blanco para los pilotos atacantes de cualquier lado que los portaaviones enemigos, y para los japoneses no había precio demasiado alto para lograrlo.
Aboard the Bunker Hill, we would have had approximately 16 5-inch guns and about 40 sets of quad 40s and over 120 millimeters. So when you set up a curtain, it was really pretty good. But the kamikazes were, you could actually have them in flames and that. You'd have to blow them out of the sky or they would just continue in.
El fanatismo de los pilotos japoneses era difícil de confrontar o contener, al igual que algunos de sus aviones. El arma mortal del Japón, el Zero, había ganado supremacía en la primera parte de la guerra, y en efecto, ninguno de los aliados tuvo nunca un avión que pudiera superarlo. La siguiente generación de aviones Grumman, el Hellcat, posiblemente hubiera podido competir con el Zero, pero no se desplegó hasta el final de la guerra. La habilidad gimnástica de la aviación japonesa pudo ser neutralizada y el asunto se resolvió con el uso de los Hellcat en parejas, a sus más altas velocidades y con mejor capacidad de fuego para abatir el superpoder de los bombarderos de Mitsubishi. Un pase de alta velocidad permitía a los pilotos norteamericanos alcanzar a los Zero, y entonces el Hellcat podía utilizar su poder para escapar y regresar un segundo después para un segundo pase. El sacrificio del peso y blindaje en el Zero lo hacían un blanco fácil, y los cañones de los pesados aviones norteamericanos no necesitaban darle muchos golpes para desbaratarlo. Los japoneses perdieron sus aviones frente a las tácticas norteamericanas, y los pilotos japoneses, con su experiencia de combate, que data desde comienzos de los 30, no pudieron con ellos. Con mucha más experiencia, sin escasez de aviones o combustible, los norteamericanos enfrentaron una resistencia decrecientemente efectiva. El resultado era inevitable. Para 1945, los portaaviones norteamericanos que ahora llevaban Corsair, junto con Hellcat, rodearon las islas japonesas. De no haberse dado las explosiones atómicas, sin duda el poder aéreo de la Fuerza Naval y la capacidad de los bombarderos de largo alcance habrían preparado el camino para la invasión. Los bombarderos Grumman, el F4F y el F6F sostuvieron la línea contra la carnicería japonesa. Al comienzo de la guerra y solos, lucharon las batallas navales cruciales de la guerra. Incluso cuando estuvo disponible el más avanzado Corsair, los Cats continuaron jugando un papel importante. Vuelo tras vuelo, la solidez de su diseño y construcción traían de regreso a pilotos que hubieran desaparecido en otros aviones. Ciertamente, los bombarderos norteamericanos sobrevivían a daños que hubieran acabado con su oponente japonés. La supervivencia de los pilotos norteamericanos hasta que adquirieron experiencia en combate fue muy importante. La primera producción de Hellcat emergió en octubre de 1942 y el último se manufacturó en noviembre de 1945. Su primer vuelo de combate no se hizo hasta agosto de 1943. Sin embargo, de los 6.477 aviones japoneses derribados por la Fuerza Naval norteamericana en el Pacífico, más de 5.000, sobre el 80%, encontraron su suerte en manos del sobresaliente bombardero de Grumman, el F6F Hellcat.
F6F Hellcat.